Hello viewers, Wagadaruna taking you through the story for Alevel Subsidiary Mathematics. And this video I'm going to go through the topic of scatter graphs and correlation. So this video is suitable for students in both Senior 5 and Senior 6 offering Subsidiary Mathematics. So before we start, let's first look at the course outline and our progress so far on this platform. So Subsidiary Mathematics is divided into three parts. The first part is pure mathematics, where 4 questions come in section A, 4 in section B, and these are the topics. The next part is mechanics, where 1 comes in section A, 1 in section B, and these are the topics. And the last part is statistics and probability, where 3 come in section A and 3 in section B, and these are the topics. So what is ticked is available on this platform, and what has a half tick means the video is going to be remade. So if you need any of the videos which are ticked, at the end of this video there will be an end screen which is like this. So if the topic is in statistics, you can get here, pure math here. Here I didn't put mechanics because we have not yet put mechanics. So if it is probability, you can get it from here. Now statistics and probability. For statistics, these first 4 are the ones for statistics, and these ones are the ones for probability. So if you need a video in this part, double click on the one of probability. If you need a video in this part, double click on the one of statistics. So in this video, I'm going to go through the topic of scatter graphs and correlation. So now shall start our topic, scatter graphs and correlation. So correlation may be defined as the degree of relationship. So the key word here is the word relationship. That's what correlation means, between two variables. The correlation can be positive or negative or zero depending on the shape of the scatter diagram, or what we call the scatter graph of the given variables. So like we said, the correlation can be positive, negative, or zero. So we shall look at all of them, but let's first look at the positive linear relationship. Now here, it is advisable not to use the word correlation. You have to use the word linear relationship, and we shall see why. So in this positive linear relationship, small values of y correspond to small values of x. Therefore, if you have your graph where you have the y-axis and the x-axis, a small value of y corresponds to a small value of x, and also a large value of y corresponds to a large value of x. So it can be like here. Now if I draw a line through those points, you realize that it has this line has a positive gradient. So that is why we call it a positive linear relationship, because if you draw a line of best fit through the points, you'll get a positive gradient. So how is a scatter diagram like? So scatter diagram, you'll have two variables, x and y, and there will be a number of points. So they'll always give you points to plot, as we shall see later in this video. So when they give you points to plot, you look for a way of enclosing them in a certain region. So if you look at this oval, it is tending in the positive side. So if you want to draw a line of best fit, it will have a positive gradient. Now what does that mean? It means that this scatter diagram has a positive linear relationship between these two variables, x and y. So this is very vital, because sometimes they will tell you to draw a scatter diagram, and after that they tell you to comment on the relationship between the two given variables. So you have to know whether it has a positive linear relationship or a negative linear relationship or no relationship. So that is positive. What about negative? So for a negative linear relationship, it means that it will have a negative gradient. What does that mean? It means that a large value of y corresponds to a small value of x, and similarly a small value of y corresponds to a large value of x, as you can see it here. So in that case, the line through will have a negative gradient, and that's where the word negative linear relationship comes from. So if I plot my points and they are in this form, I can easily enclose them in this region, and with that you realize that the points tend to have a line of base fit which has a negative gradient. Now because the gradient will be negative, it implies that the relationship between the two variables of x and y will be a negative linear relationship. That has been negative. Now we shall go to zero relationship, or what we call absence of correlation. In other words, there is no relationship, there's no way you can get a relationship between the given variables. So in this case, the graphs are a little funny. For example, if you look at this graph, to enclose the points, to enclose all the points, you realize that it makes something like a U shape. So here there is no way you can say that it has a positive gradient or negative gradient. Similarly, you can also draw a graph like this, and when you enclose it, it will just be a circle. So even here, there is no way you can identify whether it has a positive, the line of base fit will be a positive gradient or a negative gradient. Now in that case, we shall say that there is no relationship or zero linear correlation. But like I said, you don't use the word correlation, you use the word relationship. Now this one is just theoretical, but what is set will be the first two, that is positive and negative linear relationship, as we shall see in the questions. So that has been scatter diagrams. Now we shall go to Spearman's rank correlation. Now scatter diagram is just a sketch, but our interest is called a scatter graph, which we shall see after this. So Spearman's rank correlation coefficient. Here we shall show that given a set of bivariate data, bivariate means that it's a pair. Like we see here, x and y is one pair, another pair has also x and y variable, x and y variable, x and y variable. So that is what we call bivariate data. The Spearman's rank correlation coefficient, which is given by this symbol rho, can be calculated by the following steps. So the first step is to rank x and y values separately in the order of size. That means that you start with the largest, or the largest is given the first position and the smallest is given the last position. In other words, it's like you are arranging in descending order. But sometimes you may have data values which are identical. What do you do in that case? So for identical values, there would be position. Note this word would be. It's not the actual position, but the would be position are averaged such that a similar rank is allocated to them. For example, if I have a value of 60 and 60, okay, let me say 65, then 60, 60, then 55. And I want to arrange in descending order. This is already descending order, and this will be position 1. But the question is, what position would I give this? Because if I give this one 2 and this one 3, it will be unfair. Why is it that same values have different positions? So that is why we say that we get the would-be positions and we average it such that both get the same rank. So in this case, the would-be position of this 60 is 2, and for this 60 is 3. So when you average it, you'll come up with 2 plus 3 over 2, which is 1.5. So what does that mean? It means that instead of putting 2 here, you are going to put 1.5 and also 1.5 here. We shall see this in details as we go through the worked examples. So let's go to the second step after doing that. Now after ranking, what we do is to find the squares of the differences of the corresponding ranked pairs. Remember, you have a rank of x and a rank of y. Now when you subtract the two, that is what we call the difference. But they said this, they also talked about the square. So you get the difference, and after getting the difference, you have to square it. It seems a little confusing, but when we do worked examples, it will become easier and easier to understand. But we cannot go through the examples before we do the theory part. So those ones will be given by letter D. So for this one, the ranks of this one, difference will be D1, but I have to square it. For this, the rank of this difference will be D2, and I have to square it. For this, difference will be D3, and I have to square it, and so on up to the last value. So that has been step 2. Now we shall go to step 3. Step 3 says calculate the sum of the above squares. So the sum will be given by this summation. So this summation means that you are adding up all these values to get the summation of d squared, and then evaluate Spearman's rank correlation coefficient, which is given by this symbol, using the formula. So it has a formula, and that formula is this: that Spearman's rank correlation coefficient is equal to 1 minus 6 multiplied by this summation, which I've got here, everything divided by n. Now n is the number of ranked pairs. Like I told you, this is one pair, this is second pair, third pair, up to n. So in this case, it means that there are n pairs. That's what we put here. If there are 3, you put here 3, like that. So it will be n in brackets n squared minus 1. So what you should realize is that this fraction does not affect this one. Most students make a mistake and they elongate this line out to cover this one, so that it is 1 minus this, everything divided by this, which is not okay. The division is only on this 6 times summation of d squared. And the good thing is that this formula is also available in your mathematical logbooks. So now shall go to the next part, which is how to obtain comment for a given rank correlation coefficient. Now this rank correlation coefficient is the Spearman. So sometimes they can say Spearman's rank correlation coefficient, or they simply say rank correlation coefficient. So you have seen how to calculate it, but in the questions they will first ask you to calculate it, and after that they tell you to comment, just like it was for scatter diagrams. They will tell you to draw a scatter graph, and after that they tell you to comment. So even here, after calculating, they can tell you to comment on your result. So the question is, how do you comment? So you come and say that after calculating the Spearman's rank correlation coefficient, the comment is made based on the standard value of the significance levels for correlation coefficients as shown below. So in your mathematical logbook, there will be this table having a heading of significance levels for correlation coefficients. So this is the table of interest, and there's no way you can comment without this table. That means that if you're in S5, it is advisable that you buy this mathematical logbook, and the good thing is that they allow you to go with it in your examination room. Okay, so the first thing to do is to realize the number of pairs are here. These are the number of pairs. There can be 5, so the 5 is the minimum, 6, 7, 8 up to 12. Now this one, we don't need it. It is no longer on syllabus. It was some time back, but now it is no longer there. Even this one, candles, is also no longer on syllabus. So in this table, our interest is this column of Spearman's rank correlation coefficient and this column of the number of pairs. And the procedure is as follows. So the first thing to do is to determine the number of pairs of the ranked correlation n, and in the column okay. So this number of pairs is always given in the question. You have to count them and see, as you have seen in the worked examples. So this theoretical part, it may seem disturbing to understand, but you just listen, and when it comes to worked examples, you'll easily understand what I mean. So step 2, determine the corresponding standard table value of the Spearman's rank correlation coefficient at either 5% or 1% level of significance. I think you remember in your table there were 2 columns and of Spearman's rank correlation coefficient. One was 5%, another one was 1%. So the question can specify that they want you to comment at 5% or to comment at 1%. Then step 3, compare this table value. So this table value is rho t with the calculated value, which is rho c, for a particular level of significance. Like I told you, you have to choose either 5% or 1% depending on the question. If the magnitude, this is the most crucial part, magnitude. Why? Because what you calculate can either be negative or positive. But when you're using the table, we consider the magnitude. Now magnitude means, in this case, what is negative becomes positive, or what is negative you take it as positive. So if the magnitude of the calculated value, which is this, exceeds the table value, which is rho t, then the correlation is significant at that level of significance. Otherwise it is not significant. So let's look at the 4 comments which may arise. One is when the magnitude is greater than the table value at 5%. In that case, the comment will be significant at 5%. Now most students, when they hear the word comment, they may think you write a very long sentence, but here what we need is only this, so you must be as brief as possible. Significant at 5%, and that will be your comment. Then the second case is when the calculated value is less than the table value at 5%. In that case, the comment will be insignificant at 5%. So we begin with the word in. So you can either use this or you can use the word not significant. So any of the 2 is okay. You can say insignificant at 5% or not significant at 5%. It is just English which is changing. So then the third part is when the calculated value is greater than the table value at 1%. In that case, the comment will be significant at 1%. And the last case is when the calculated value is, the magnitude of the calculated value is less than the table value at 1%. In that case, the comment will be insignificant at 1%, or you can say not significant at 1%. So these are the comments which we expect. You can either write, it can be this or this or this or this, as we shall see in the worked examples. So now that you have learned how to now that we have got the formula for calculating Spearman's rank correlation coefficient, and we have also seen how to comment, now it's time to go through some of the questions to apply the formula and also get the comment. So question 1 says, the table below shows the original marks of senior 6 candidates in 2 examinations, that is biology, and these are the marks, and chemistry, and these are the marks. So I think these are 6 pairs. There is 1, 2, 3, 4, 5, 6. So 6 pairs. Now 6 pairs, that is the value of n, so n will be 6 because n means number of pairs. Okay, then calculate the rank correlation coefficient. Like I told you, here they can either use the word Spearman's rank correlation coefficient, or they can simply say rank correlation coefficient. It is the same between the marks of biology and chemistry. Then comment on your result. Note that here they have used the word comment. Most students confuse it with the word comments. Now comments means is more than one, but comment means it is singular. They want only one comment. If you write more than one comment, then it will be vague. There will be no mark given here. So let's see how such a question is answered. First we shall say, remember we used 2 variables x and y, so let x denote biology marks and y denote chemistry marks. So in that case we shall tabulate. So in this topic you have to tabulate. Now for the column of x, we are going to get these very values of biology and write them going downwards. So let's do that. Okay, then next will be y. Now for y, we shall get these very values of chemistry and write them going downwards. Okay, so that is what was given. Now next is step 1. Step 1 said we have to rank. Now Rx means rank of x. It is a symbol to denote rank of x, and it is known. So rank of x means, remember we said you have to rank in descending order. So the largest value is given the first position, and the smallest is given the last position. So in this case of all these values, you have to locate the largest. So the largest is 62, and that will be given position 1, or a rank of 1. Then the second largest is 59, so it will be given a rank of 2. And the third will be 56, it is given a rank of 3. Next is 48, it will be given a rank of 4. Next is 42, it is given a rank of 5. And lastly, 38 is given a rank of 6. So that is the ranking for these x values. Now we shall go to the y values. So the largest is 84, so it's given a rank of 1. Next is 80, rank of 2. Next is 73, rank of 3. Next is 69, rank of 4. Next is 64, rank of 5. And lastly 68, 60, rank of 6. So ranking, that's how they rank. You rank in descending order. The largest takes the first rank, and the smallest takes the very last rank. Okay, now that you have finished step 1, step 2 in calculating, they told us to get the square of the differences between these ranks. Now for you to get the squares, it is advisable to first get the difference. So we are going to first get the difference. Difference will be Rx minus Ry. So this minus this gives you 1. This minus this gives you 0. This minus this gives you 1. This minus this is negative 1. This minus this is negative 1. This minus this is 0. Okay. but our interest is the square of the difference. So these are the differences, but we are interested in the square, so we shall get a column of d squared. Then we shall start squaring. This squared is 1, this squared is 0, this squared is 1, this squared is 1, this squared is 1, and this squared is 0. Okay. Then from there, I think you remember they told us you have to get the sum of the square of this. So you have to sum them up. So when I add all these values, I'll come up with a sum of 4, and I'll call it summation of d squared, meaning that I'm summing up all the values of d squared. Okay, so that is the table we want. Next is to answer the questions. So remember that as for rank correlation coefficient, so first of all is to quote the formula correctly. If you have forgotten it, you can get it from your mathematical table. The next is to substitute. Our d squared, summation of d squared is 4, so I'm going to come and substitute there 4. Then our pairs, n is 6 because number of pairs. This is 1 pair, 2, 3, 4, 5, 6. That is why you see this 6. This 6 is a standard, it's part of the formula, so you don't mind about it. But this n depends on the number of pairs. It can be 6, 7, 8, 9, 10, up to 12. So the values of n range from 5 to 12 based on the syllabus. Now when I use a calculator, I'll come up with this. Now most students, the mistakes most students make here is to write the answer in fraction form. It is true that in math, an answer written in fraction form is the most accurate. But when it comes to Spearman's rank correlation coefficient, it is not advisable, or it is not allowed to write your final answer in fraction form. Now why is it so? It is because they will always ask for a comment, just like it is here. They have asked for the comment, and when you look at the values in your mathematical table here, they are all in decimal points. There is no fraction here. Now if you leave your answer in fraction form, there is no way you can compare it with these values. So that is why you have to write your answer in decimals when it comes to Spearman's rank correlation coefficient. Now the question is, how do we comment? First of all, you have to know this value. It is 0.8857. That is the calculated value. What about the table value? Now the table value, you'll come here and first look at your number of pairs. Number of pairs is 6. So I come here, there is this for 5% and also this for 1%. Now this will be the table value, and in this case the calculated value is 0.885. So that means that this calculated value is smaller than the table value. Now because it is smaller, we shall see the comment will be insignificant at 5%. That is if you are using this column. What about when you are using this column? Still the table value, the calculated value is smaller than this table value, therefore you will also say insignificant at 1%. But remember, they said comment, and comment is singular. So I shall come here and comment. Either I can comment at 5% and it will be insignificant at 5%, or I can come and comment using 1%, so it will still be insignificant at 1%. Remember, it is comment. You either write this or you write this. So if you write both of them, that will be wisecking, and what the examiner will do is to just cross everything because I'm not sure. So that has been question 1. Then question 2. Below are the marks of 8 students in economics and geography in the end of term examination. So these are the marks of economics, marks of geography. Calculate the rank correlation coefficient between the marks of economics and geography in the end of term this word math is not there, and comment on your result. So still we shall tabulate our values. So let X denote economics and Y denote geography. So we shall come and draw our table, then start with the X values. So X, we shall put their marks for economics. So let's do that. The next will be Y. So for Y, we shall put their marks for geography, which are these ones in order. Okay, now next is to rank. Rx means rank of X. So I'll come at these values, look, identify the largest. So the largest is 81, give it rank 1. Next is 75, give it rank 2. Then next is 65, give it rank 3. Next is 60, give it rank 4. Next is, now here in question 1 there were no identical values, but here we have now identical values. There is this identical 52 and also here 52. Now the question is, what do we do? The first thing what to do, we said we have to average the would-be position. Now the would-be position of this can be, okay, we stopped at 4, so one can be 5 and the other takes 6. So these are the would-be positions. What we do, we come and add the 2 and then divide by 2. So when I add them and divide by 2, I'll come up with 5.5. So what does that mean? It means that both this will and this will take rank of 5.5. So this was 5.5 and also here 5.5. So that is how they deal with identical values. And next is 41. Now 41 takes 7. Why? It is because 5 and 6 were already taken by these which were identical. And lastly is 31, which takes rank 8. Okay, so now we shall go to rank of Y. So Y still will do the same. Identify the largest is 72, give it rank 1. The next will be 63, give it rank 2. Next will be 60, give it rank 3. Next will be 55, give it rank 4. Next will be 54, give it rank 5. Next will be, now here still we have 40 and 40. So we stopped at 5, meaning that one would have taken 6, another one would have taken 7. But we can't do this, so what we do, we have to add them and divide by 2. When I add and divide by 2, I'll come up with 6.5. So that means that I'll put here 6.5 and also here 6.5. Now position 6 and 7 have been taken, meaning that the next will be 8. So that means that this 35 will take rank 8. So that is how they rank identical values. I think by now you have got the concept. Next will be the difference. So this minus this gives you that, this minus this gives you this, this minus this gives you this, this minus this gives you that, this minus this gives you, this minus this gives you, this minus this gives you that, and this minus this gives you this. Okay, but our interest is on the square of the difference. So I'll come and get the column of this squared. This squared gives you this, this squared, this squared, this squared, this squared, square this, square this, square this. Okay, then next I have to get the sum of all these ones. So I'll get my calculator and add up all these values. When I add them up, I'll come up with 68 as my summation of d squared. Okay, now that I've got summation of d squared, I'll come and quote the formula and then substitute for 68 there. Now 8 is because of the pair. This is 1, 2, 3, 4, 5, 6, 7, 8. There are 8 pairs, that's why you put 8 here. The next is to use the calculator, and I'll come up with this. Like I said, the answer must be in decimal points, not fraction. Then now I'll have to comment. So to comment, I'll go back to my mathematical table. First of all, the calculated value is 0.1905. So I'll come here and say, look for the number of pairs 8, and then use either this or this. Now the calculated value of 0.19, let me first see, is 0.1905 is smaller than this, meaning that the comment will be insignificant at 5%. It is also smaller than this, meaning that the comment will be insignificant at 1%. So I'll come and choose any of the two. So if I use 5%, I will say insignificant at 5%. If I use 1%, I will say insignificant at 1%. So you remember, you have to choose only one of the two, not both of them. For me, I'm writing both because this is just a guide, it's a lesson. But in an exam, choose one comment. That was question 2. Now we shall go to question 3. It says 8 schools participated in athletics competition in 2010 in a certain district and obtained the following scores. In a 100-meter race, these are the scores. 800-meter race, these are the scores. Calculate the Spearman's rank correlation coefficient for the school's performance in the 2 races and comment on your results. So always they will tell you to comment. That means that you have to go with your mathematical logbook in an examination for you to be able to comment. So like the procedure has been, we have to tabulate our values. So we shall use X to denote 100-meter race and Y to denote 800-meter race. Therefore, under X, we shall put the values for the score for 100-meter race. And for Y, we shall put the scores for 800-meter race. The next is to rank. Now to rank, I'll have to look for the largest in this. So it is 48, so 48 takes rank 1. The next is 45. Now 45, there are 2, meaning that the would-be position would be one would take 2, another one would take 3. So what I'm going to do, I'll get their average. And average is 2.5, meaning that both of them will take 2.5. Put 2.5 here and 2.5 here. Now position 2 and 3 has been taken, meaning that the next will be position 4. So position 4 is also funny because we have 2 values. So what we do, one would be 4, another one would be 5. So next is to get the average. So when I get the average, I'll come up with 4.5. What does that mean? It means that this one will take 4.5, this one will also take 4.5. Now position 4 and 5 have been taken, meaning the next will be position 6. Therefore this will take position 6, this will take position 7, and lastly this will take position 8. That is the rank for X. What about Y? So for Y still you do the same. Look for the largest. 75 takes rank 1. Next is 68, take rank 2. Next is 60, takes rank 3. Next is 58, takes rank 4. Next is 57, takes rank 5. Next is 54, takes rank 6. Next is 48, it takes rank 7. And next is 40, it takes rank 8. Okay, now that I finished the rank, next is to get the difference between the two. So this minus this will give you this. This minus this gives that. This minus this gives you this. This minus this gives you that. 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 And this minus this gives you that. Okay, but our interest is the square of the differences. So I'll get the column of this squared. So this squared give this square of this, 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 square of this. Okay, now next is to use the calculator and add up all these values. So when I add them up, I'll come up with 35. After that, I'll go to my formula and then substitute. Now 8, because there are 8 pairs, 1 2 3 4 5 6 7 8. That is why where there is n, I'm putting there 8. Then I use the calculator to get this value, and that will be the answer. Now next is to comment. So commenting still, I'll go to my table. So the calculated value is 0.5833. So I'll come here, look for my number of pairs 8, and I'm interested in this value and this value. You realize that the calculated value is smaller than this, and it is also smaller than this, meaning the comment will be insignificant. Therefore, I'll come here and say insignificant at 5%. That is if I wish to use 5%. Alternatively, I can say insignificant at 1%. So you only choose one comment, because this word comment is singular. If you write both, then you'll have lost the mark. That was question 3. Now we shall go to question 4. So question 4 says, the table below shows the performance of 10 students in their inter-house music competition and their performance in their end-of-term math exam. So the performance for music and this one for math. Calculate the rank correlation coefficient between the students' performance in music competition and their performance in end-of-term math exam. Then comment on your result. So just still do the same. We have to tabulate our values. So X we shall denote music and Y denotes math. Therefore, for X we shall put there the marks, the scores for music. Then for Y we shall put the scores for math. Then after that we shall get the ranks for X. So for X we shall analyze these values, start from the largest to the smallest. So the largest is 280, so it takes rank 1. The next is 276, it takes rank 2. Next is 270, it takes rank 3. Next is 250, it takes rank 4. Next is 232, it takes rank 5. Next is 228, it takes rank 6. Next is 220, it takes rank 7. The next is 150, but 150 they are 3, so one would take, we have subtracted 7, so one would take 8, another one would take 9, another one would take 10. So these are the would-be position. What we do, we have to get their average. So 8 plus 9 plus 10 over 3 gives you 9. So that means that this will take 9, this will also take 9, and this will also take 9. Okay, so we are done with the rank of X. Now next is the rank of Y. So still rank of Y, the largest are 3, so this would have taken position 1, this one would have taken position 2, and this would have taken position 3. But that can't be, so we have to get the average of all those ones. So the average would be 2. So what does that mean? It means that here we shall put a rank of 2, here we shall put a rank of 2, and here we shall put a rank of 2. The next is 64. Now we have already used 1, 2, 3, so next is 4. So this will take rank of 4. Next is 61, takes rank of 5. Next is 55, it takes rank of 6. Next is 52, it takes rank of 7. Next is 50, it takes a rank of 8. Next is 48, it takes a rank of 9. And next is 40, it takes a rank of 10. Okay, now next is to get the difference. So this minus this gives you that, this minus this, 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 and this minus this gives you that. Okay, but our interest is the square, so we shall get a column of this square. So this square of this, 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 square of this. Okay, now next is to use your calculator and you add up all these values. So when I add them up, I'll come up with 26. After getting that, I can code the formula and then substitute. Now here the value of n is 10, because when I count pairs 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They are in 10 pairs, that's why where there is n we put there 10. Using a calculator gives you this. The answer has to be in decimal points. Now next is to comment. So I have 0.8424 as the calculated value. What about the table value? So for the table value, we shall come and look at our number of pairs of 10. We are interested in this value or this value. Now in this case, the calculated value, if you look at this, the calculated value is 0.8424 and it is bigger than this. The calculated value is bigger than this, meaning it will be significant. Then also bigger than this, meaning it will be significant at 1%. Therefore, when it comes to the comments, we shall say significant at 5%, or we can say significant at 1%. But don't write both. So that was question 4. Now we shall go to question 5. So question 5 says, the table below shows the oral interview rank X and written interview rank Y for 12 candidates. These are the candidates, and these are the ranks. Calculate Spearman's rank correlation coefficient and comment on your result. Now this one is a little tricky. Why? Because they have not given us the score, they have given us the rank. Not this word rank. So what does that mean? It means that these are the ranks, so you go straight to get the difference. So you shall first put the candidates A, B, C, D up to L. Then you shall put the rank of X as it was given in the question. Then the rank of Y as it was given in the question. Then next is to get the difference. So this minus this, 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 and this minus this. But our interest is the square of the differences, so we shall come and get the column of d squared. So square of this, 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 square of this. Okay. The next is to use the calculator and add up all these values. So the sum will be 46. Therefore, I can code the formula and substitute, then use a calculator to come up with this value. The next is to comment. So the calculated value is 0.8392. The number of pairs are 12. So go in my table and look for a pair of 12. I'm interested in this value and this or this value. So the calculated value is bigger than this, so it is significant at 5%. It's also bigger than this, so it is significant at 1%. Therefore, I'll come and comment. So shall come and say that significant at 5% or significant at 1%. So remember, you have to choose only one comment. So that was question 5. Now we shall go to question 6. It says that table below gives the points awarded to 8 schools by 3 judges, J1, J2, and J3, during a music competition, and J1 was the chief judge. Okay. Part A. Determine the rank correlation coefficient between the judgments of J1 and J2. That was Roman 1, then Roman 2. Between J1 and J3. Then part B. Okay, let's first do part A. So for part A, we have to tabulate. So here we have to tabulate. So you first start with the marks, the scores from judge 1. So those will be the scores. Then the ones from judge 2 will be those ones. So these are the very ones given in the question. Then from judge 3, these will be the scores. Okay, so now we are going to rank. We shall start with J1, so we have to rank them. So the highest is 82, so it takes rank 1. The next is 72, but there are 272, so one would take 2. Another one will take 3, meaning I have to get the average of 2 and 3, which is 2.5. Therefore, this will take 2.5, and this will also take 2.5. Now, position 2 and 3 has been taken, meaning next will be 4. Therefore, 55 will take 4, and 50. Now, 50 there are 2, so one would be 5, and another would be 6. So, get their average is 5.5, therefore both will take 5.5. This will take 5.5, and this one also 5.5. The next is 38. Now position 5 and 6 have been taken. This will take position 7. Then this one will take position 8. Okay, so that is the rank for judge 1. What about judge 2? So judge 2, the highest is 73, so it takes 1. Next is 70. There are 2 70s. One will be 2, another one will be 3. So the average is 2.5. So 2.5, you will come here and put here 2.5, and also here 2.5. Then 2 and 3 has been taken, so this will take position 4. Then this one will take position 5. Now this 150, there are 3, so one would have taken position 6, another one 7, another one 8. So I have to get their average, and the average is 7, meaning this will take 7, this will take 7, and this will take 7. Now I shall go to judge 3. So judge 3, the highest is 70, so it takes rank 1. Next is 67, there are 2, so one would be 2, another one would be 3, so the average is 2.5. Therefore, this will take 2.5, and this one also 2.5. Now position 2 and 3 have been taken, so next will be position 4. Therefore, this will take 4, this will take 5, this will take 6, and this one would be 7, and this one another one would be 8. So the average of the two would be 7.5. That means that this will take 7.5 and this one also 7.5. Okay. Now they wanted the rank correlation between J1 and J2 and also J1 and J3. So we shall get the difference between J1 and J2. Therefore, this minus this gives you this, 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 this minus this gives you, this minus this gives you, and this minus this gives you that. Okay, now we shall go to the difference between J1 and J3. So this minus this gives you this, this minus this gives you that, this minus this gives you, 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 this minus this gives you that, and this minus this gives you that. Okay, but our interests are the squares, so I'm going to square this column. So square of this, 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 square of this. Now next is use the calculator, add up all these values. So when I do that, I'll come up with 21.5. Then also I have to square this column. Therefore, I come and get that column and the square of this, 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 square of this. Then next is to use the calculator and add up all these values, and it will be 25. So now that I've got these summations, we can go and answer the questions. So part A, they wanted the rank correlation coefficient between J1 and J2, and then Roman 2, J1 and J3. So let's first do that. So for J1 and J2, come and code the formula, then substitute for the summation and for n to come up with this as the required value. Then for Roman 2, J1 and J3, still code the formula, substitute to get this value. So that was part A. Now let's go to part B. So here they didn't tell us to comment. Then part B says, who of the two other judges had a better correlation with the chief judge, and give a reason. So there we shall go and compare the values. Then we shall say that judge 2 has a better correlation with the chief judge. They also told us to give a reason. So this is because the rank correlation coefficient between J1 and J2 is greater than that between J1 and J3. So this one is bigger than this. Therefore, this had a better correlation with J1. So that has been Spearman's rank correlation coefficient. Now we shall go to scatter graphs. Now, like we said, this is a graph involving location of one variable on the vertical axis and the other on the horizontal axis. When the values of y are plotted against the corresponding values of x, a scattering region is formed which can enable us to identify the type of relationship. Note that we're using the word relationship. So like I will say, this one is a positive linear relationship and this is a negative linear relationship. Now here they will also tell you to draw the line of best fit. So here we need to go through a number of steps. So let's look at these steps. So it is evident that if we can draw the scattering region, a line which adequately fits the data, if you can draw in a scattering region a line which adequately fits the data, this line will be called the line of best fit and can be drawn in the scattering region by going through the following steps. So there are some steps you need to take for you to draw your line of best fit. It is a little different from the one of physics. So step 1, find the mean point x bar, y bar, where x bar is the mean of the x values and y bar will be the mean of the y values, n being the number of observations. Then step 2, draw a straight line through the mean point M and any one or more points plotted, ensuring that they are equal or almost equal. Now this line is what disturbs students. The word equal or almost equal points on either side of the line, so left above or below or left and right of the line. So equal or almost equal means if I have 4 points this side, I should have 5 points there this side, so that is almost equal. Then equal means if I have 4 points this side, I'll also have 4 points this side, so that is what equal. This is equal and this is almost equal. They must differ by 1. But we shall see that in the worked examples. Then step 3, in cases where it is impossible to achieve step 2, the line of best fit will thus be got by drawing a straight line through any 2 or more points plotted, ensuring that they are equal or almost equal. So still this condition has come up. So this condition is very vital when it comes to drawing line of best fit. Now sometimes if you want to draw your line to pass through the mean point, it may not be able to pass through any other point for it to be okay, for it to leave equal or almost equal points on either side. So that means that you just choose any 2 points, any 2 or more points, and draw your line of best fit through those points, ensuring that still it is equal or almost equal. So this is theory and can be hard to understand it until you do worked examples. So let's go straight to the worked examples. Question 1 says, the table below shows the scores of 10 students A to J in physics and mathematics tests. Those are the scores. Then part A, Roman 1, plot a scatter diagram for the given data. Comment on the relationship between the scores in physics and math tests. Roman 2, draw a line of best fit on the scatter diagram. Roman 3, estimate the score in math for a student who scored 37 in physics. Then that was part A. Part B, calculate the rank correlation coefficient for the data and comment on your result. Now because they want this rank correlation coefficient, the first thing to do before anything else is to tabulate. So let's go and tabulate. So the students A up to J. Then we shall have X. I think by now you know what X means. No, so X, if you look at this table, let's first go up. So X, they defined X as the marks of math and Y as the marks of physics. So X are these marks and Y are these marks. But now here, because we have to get the mean point, we have to also get the summation of X. So add all these values to come up with this value. So this will help us to get the mean point. Then for Y, we still put those values there for Y. Then add all these values to come up with this as summation of Y. Then now we are going to rank. So ranking, I believe by now you know how to rank, so I'll just list them down. We already covered ranking. Then ranks for Y, still I believe you know how to rank, so I'll just list them. The next is D, so D still I believe you know how to get D, so I'll just list them. And lastly, D squared, I believe also you know how to get D squared, so I'm going to just list it down. Then I have to add all these values to come up with summation of D squared. So now that you have finished tabulating our values, we can go and answer the questions in order. So part A said, plot a scatter diagram for the given data, then comment on the relationship between the scores in physics and mathematics. So let's just go do this part of plotting the scatter diagram. So to plot, you will need a graph paper. Then you will draw the horizontal and y axis. Then get a scale for the horizontal axis and label it. Then get a scale for the vertical axis and label it. Now next is to plot. Now to plot, you shall plot values of x and y. Remember, x were for math, meaning the x values are for this horizontal, then y were for physics, so they are for this vertical. We are going to plot pair by pair, so we shall locate 28 on the x-axis and 30 on the y-axis and come up with this point. So this is 28 x-axis and 30 y-axis. Then another point is 20, 20, so 20 on the x and 20 on y, which gives you that point. The next is 40, 40, so 40x, 40y to give you this point. The next is 28, 28, which gives you this point. The next is 21, 22, which gives you this point. The next is 31, 35, which gives you this point. The next is 36, 35, which gives you this point. The next is 29, 27, which gives you this point. The next is 33, 31, which gives you this point. And lastly is 24, 23, which gives you this point. Okay, so that is a scatter diagram. And I think we realized that if we are to draw our region covering all the points, it will have a positive gradient. Therefore, when it comes to this part, let's go to the question. So when it comes to this part of commenting on the relationship, we shall say there is a positive linear relationship. Therefore, we shall come here and make our comment that there is a positive linear relationship between the scores in math, in physics, and math test. So that was Roman 1. What about Roman 2? So for Roman 2, they say draw a line of best fit on the scatter diagram. So line of best fit, we have to first get the mean point. Mean point, you are going to use these values, summation of x and summation of y. Therefore, you come and say that x bar is summation of x over n, which is 290 over 10, which gives you 29. Then y bar, it is 291 over 10, which gives you 29.1. So we shall come here and add that point on our graph, and to be this point. Now the line of best fit must pass through this point and any one or more points, leaving equal and or almost equal points on either side. So when you draw, for example, this line, it is passing through the mean point and this point and also this point. How many points has this left this side? There is 1, 2, 3. What about this side? There is 1, 2, 3, 4. So this side it is 3, this side it is 4. That is what they mean by almost equal. The difference must be 1. If here it was 3 and here it was 5, then that line of best fit will be invalid. So you have to look for another line of best fit. Okay, then another thing is that the line of best fit, it is not a must that it will always be this, but as long as it leaves equal or almost equal points on either side, then you are correct. Then now shall go to Roman 3. Roman 3 says, estimate the score in math for a student who scored 37 in physics. So shall come in the axis of physics, look for 37, then take a horizontal line to meet the line of best fit. Then drop a perpendicular to meet the horizontal axis. Then read off that value, and that will be the value they want. Therefore, shall come here and state that the score in mathematics for a student who got 37 in physics is 37. Then now shall go to part B. So this is part B, not C. So part B, they wanted the rank correlation coefficient for the data and comment on your result. The good thing, we know summation of d squared, so we shall come and substitute for summation of d squared as 10 and also the number of pairs as 10 to come up with 0.9393. Then for commenting, you'll come here, get your mathematical logbook, pairs at 10, so you're interested in this value and this value. So the calculated value is bigger than this, so it is significant at 5. It is also bigger than this, so it is significant at 1. Therefore, you shall comment that it is significant at 5%, or you can comment that it is significant at 1%. That was question 1. Now we shall go to question 2. Question 2 says the table below shows the percentage of sand. Y is the percentage of sand in the soil at different depths x. So x is the depth. Part A, plot a scatter diagram for the data and comment on the relationship between the depth of soil and the percentage of sand in the soil. I think let's first start with that. So now because they ask for rank correlation coefficient, the first thing to do is to tabulate. So we have to first tabulate what we shall use in our solution. So x, we shall put there the values of x. Then we have to get the total, which will be this, because we are going to plot. Then y, we put the values of y. Then we also get the total, which is this. The next is to rank. By now we know how to rank, so for me I'm going to just state them. Then I also state the ranks of y. Then I also state the difference. And lastly, I'll state the d squared. And get the total as 321.5. So with that, I can now go ahead and answer the questions. So first they wanted you to plot, so I'll first get the graph paper, then draw the x and y axis, so horizontal and vertical axis. Then get a scale for the horizontal axis and label it. get a scale for the y-axis and label it, or vertical axis, and label it then shall start plotting. So plotting, 35 goes with 86, so shall come and plot that point. Then 65 goes with 70, so shall plot it. Then 55 goes with 84, so shall plot that. 25 goes with 92, so shall plot this. 45 goes with 79, so shall plot this. 75 goes with 68, so shall plot this. 20 goes with 96, plot this. Then 90 goes with 58, which is this. Then 51 goes with 86. And lastly 60 goes with 77. So this one, it has the region is in this form, which is negative. Therefore, we shall come and write our comment that there is a negative linear relationship between the depth of the soil and the percentage of sand in the soil. Then they also told us to get the line of best fit, so I have to get x bar, which is 52.1, and also y bar, which is 79.6. Then I also locate it on the graph, which is here. Okay, now next is to get the line of best fit, ensuring the leaves equal or almost equal. Now my line of best fit is passing through the mean point and this point. So let's see the point this side. 1, 2, 3, 4, 5. Then what about this side? 1, 2, 3, 4. So this side there is 4 and this side there is 5. That is what they mean by almost equal when the difference is 1. If here it was 4 and here it was 6, that line would be invalid. So line of best fit is drawn. Then part C, use the line of best fit to estimate Roman 1 percentage of sand in soil at a depth of 31 centimeters. So when the depth is 31 centimeters, we shall come here locate 31 and take it upwards to meet the line. Then take horizontal line to meet the vertical axis and read of that value. It will be 91.25. So shall come and state that the percentage of sand in the soil at a depth of 31 centimeters is 91.25%. That was Roman 1. What about Roman 2? So Roman 2, they said find the depth of the soil with 54% sand. Then part C, they wanted you to calculate the rank correction coefficient and comment on your result. So here look for 54% and take it horizontally to meet this line. Then take it downwards to get this value and read it off. And that will be the depth they want. So I'll come here and say that the depth is 96.5% from the graph. Then they also wanted you to calculate the Spearman's rank correction coefficient. The good thing we got our summation of d squared, and the values of n is the value of n is that. So we shall come up with this as the value. I think we'll see that when the graph shows a negative linear relationship, even the Spearman's rank correction coefficient will be negative. Then the comment, it will be significant at 5% or significant at 1%, because when you look at your table here for 10, this value is the calculated value is bigger than this, and also bigger than this. That is why it is significant throughout. So that brings us to the end of this video. Thank you for watching, and be reminded the next video will be on price indices. So if you're not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video on price indices has been uploaded. And also, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that you can all benefit as a family.